Hello everyone, welcome to my channel. Today I'm gonna talk about a very important topic that all engineers and researchers might face in their real life, even they are working, even they are in school, which is catalyst. Each of us need a catalyst. We hear a lot about this expression, but some of us doesn't know. So we need a catalyst in our life to motivate, in our life to study hard. We have a target or a goal we need to reach, we need a catalyst, of course. It's the same for chemistry, the same for chemical reaction. It needs a catalyst in order to make the reaction easy and smooth and, done in very short time. So that's simply what the catalyst mean. So let's get started. What the catalyst mean? So catalyst is a substance that increase the rate of chemical reaction without being consumed in process. So think about it. It like we have like a two reactants need to be react together in order to make like a final product. So the catalyst is just an assistant, the both reactant to react and give us like a final product. Or we can consider it as a tray or environment that both molecules can react together and then give us a final product without being consumed. So the catalyst it will not be a part of the product or it change the structure of the final product or the structure of the catalyst itself. So it will never change the product and the rate of reaction will be increased as well. So we have also another term called catalysis. We might be confused between catalyst and catalysis, but catalysis simply means the mechanism. So actually is catalysis is a cycle process where the reactant is attached to the catalyst where happens a reaction and then product are released from the catalyst and then the catalyst will be react again with another reactant and then and then regenerate to the initial state. So make three steps. So the reactant attached to the catalyst, and then the reaction is happen. Then the product is formed and then released from the catalyst without changing the structure of the catalyst. Then the catalyst back to the initial state, which is has nothing of reaction on it in order to be ready for another reaction as well. So this diagram can show us, is a simple diagram can show us how is the catalyst work. So here we have the catalyst over here, and within we have like a two reactant. Imagine there's a catalyst, and then we have like a two molecules, this purple and this green. Then they attach to the catalyst, where the chemical reaction is happening here on the top of the catalyst, and then when the reaction is done, it released from the catalyst as a final product, and will leave the catalyst back as initial state as it is, and ready for another reaction. That's simply how the catalyst works. So of course the catalyst should be has like requirements. How we have like a good catalyst. So the good catalyst should has like some important things, which is the activity. If the activity of the catalyst can promote the final product we need or not. Because the catalyst, most likely, it has like active sites, which is responsible for making the molecules to be together. And of course, the catalyst not can be fit for any reaction. So maybe some reaction needs specific kind of catalyst. Maybe the other needs a different type of catalyst. So it depends on the active sites that makes a reaction happen, makes the molecules to be together as soon as possible, and make it smooth, and the final product can be released afterwards, and should be selective and should be has a high selectivity, especially if we have like a mixture of gases are together and the target of the reaction to um, get impurities, like in gas treatment when we has like a sulfur associated with natural gas, and we need to extract the sulfur from natural gas. So it goes through a catalyst, which is attached with a catalyst, which is in this case is a solid, and heterogeneous catalyst. We're gonna talk about this later, and the final natural gas, which is go out through the catalyst with a minimum amount of sulfur. So the selectivity, it can select whatever unneeded in the mainstream of gases, and it go out. So and go out the good natural gas we need. And stability should be resist the activation. So in the previous example, we talked about like the natural gas that associated with sulfur, and the target of this the gas goes through the catalyst, and the sulfur attached to the catalyst, and the natural gas, which is our target, go with a very mineral amount or a very fraction of sulfur. So by the time the more sulfur on the catalyst on the active side is lower the activity and lower the stability of the catalyst, which is make the catalyst is less effective and deactivate, and maybe later on the catalyst lifetime will be very short. Lifetime it will be very short. So there is three things that can affect the activity and stability of catalyst, which is the impurities in the feed, and the thermal if like exposed to high temperature process, and also if there is a mechanical movement, which is might be due like erosion and lower the size of the catalyst as well. And of course, if we talk about like previous example regarding natural gas, so we're using a heterogeneous catalyst or the solid catalyst. So the idea if we have a solid catalyst is provide a high surface area of contact that needed for any reaction to increase the rate of reaction and increase the yield and lower the side product. And a large surface area means large active size. Active size might be like precious metal, like in case catalytic converter in cars. So we use like a platinum and palladium metals, which is always used to lower the harmful uh, exhaust smoke from the car and generate a uh, good exhaust air out of the car. We have three types of catalyst. We have a homogeneous catalyst, and we have heterogeneous catalyst, and we have enzymes. Homogeneous catalyst, so the phase between the reactant and the catalyst are the same. For example, liquids. So a liquid like in acids happen. For example, how it works is so the catalyst is soluble in one in the reactant, and then react with another reactant and give us like a final product. But then in this case, we need to separate the catalyst from the final product, maybe by distillation or boiling, whatever, maybe through the boiling point distillation. Heterogeneous catalyst is having most likely by solids catalyst in gas treatment process. Like a heterogeneous catalyst is maybe in a fixed bed, and then the gas with impurities go through it. So the catalyst, what is doing, has like high selectivity, so attached to the impurities or on byproduct, whatever, and the natural gas goes through it with minimum amount of byproduct, which is the target that we need. Enzymes, something is biological, um, especially if that's what happens in our stomachs, when the enzymes um, change or transform the food into energy that our bodies needed for normal activity. Um, and then what's the importance of catalyst? For a chemical reaction, it has so many different types of benefits. The most important one is lower the activation energy of reaction. So what is the activation energy in reaction? Activation energy is the minimum energy required in order to start a reaction. It's like a step that reactant should climb in order to turn to a final product. So the catalyst, in this way, if we look to this diagram, we'll figure out that without catalyst, we found like the energy needed to start the reaction is too high. And then when the reaction happens, is go and turns into products. So that means a disappearance of reactants happen, and because the reactants, the bonds and molecules are breaking down and in their way in transforming to a product. But if we have the catalyst, which is a red curve, we'll see that energy needed is much lower. We found this amount of energy, which is saving time and saving money as well, because energy is money. Always remember this. So the catalyst is very crucial step in most of reactants, and how they discover it. So discovering, maybe this is a short story. I forgot to mention this at the beginning. So they discovered it a long time ago when they were manufacturing cheese and wine. So when they got like a previous small piece of cheese, and when they put it in the new cheese making, they figure out the time to make the new cheeses much shorter. Why? Because the catalyst is play very important role to increase the reaction of making cheese. The same with the wine as well. Um, and also increase the yield, increase the productivity of whatever final product need, and lower the side products. And the rate of reaction increase and make the speed is highest. And of course, saving time and cost, saving energy and time as well. Has so many applications. It's used in ammonia manufacturing, like in fertilizer companies, pharmaceutical companies, oil and gas, of course, regarding its absorption and the absorption process, and catalytic converter in all cars we have in, and I can add in food manufacturing as well, as I mentioned in cheese, as I mentioned before, when you do yogurt. So the yogurt they use like a previous, like a small amount of already made yogurt in order to make a new yogurt as well. Um, to recap, catalyst is very essential and very important in our life. And without catalyst, a lot of energy would be consumed. A lot of reaction might be impossible. So and is very important for in the future, even in the past, and maybe a lot of research would be happening to enhance the using of a catalyst in our real life and manufacturing more and more. Thank you, and meet you in another video. Thank you so much. Bye bye.